Welcome back to Common Core Algebra II. Today is 8.1 square root functions. So square root functions are a little bit different than other functions. You kind of have to consider what the y's are going to give or your range values are going to give when you pick certain x values, because if you pick every x value, you're going to get some crazy decimals in there, which we're not happy with. So exercise 1 says consider the two functions. So f of x is the square root of x, and g of x is the square root of x plus 3 minus 2. So A says let's graph this on the grid below. So if we consider what that table looks like, here's x, y, and if you want to put it into your calculator, you can, but I mean just doing this by hand, remember this is the one I'm looking at right here. So hopefully you remember that you can't have negatives under radical signs and have them be able to show up on a regular real number graph. So we're going to start with 0. So 0 yields 0 because the square root of 0 is 0. And this, think about 1, and the square root of 1 is 1. But as soon as I put a 2 now in here, the square root of 2 is going to give me a decimal, and the square root of 3 is going to give me a decimal, but the square root of 4 will give me a nice number. It'll give me 2. So think about it like this. If you want to consider those outputs, so what number is going to give me an f of x or a y that's equal to 3? Well, the square root of 9 is equal to 3, and the square root of 16 is equal to 4. So graphing these points, 1, 1, 4, 2, and 9, 3. So this is what my f of x looks like. Arrow. Okay. So now B says on the same graph, let's graph g of x. And it says here, start your table at x equals negative 10 to see certain x values not in the domain of this function. So what they mean by that, I'm not going to pull the calculator up because I think I can explain this to you just fine. If you do this in your calculator and you have numbers negative 10, negative 9, negative 8, all the way down to negative 5 and negative 4, these are going to yield errors in your calculator because they're going to yield numbers here. Remember, g of x is the one we're doing now. They're going to yield numbers here that are going to be negative. So you're going to get a nice big error in there. So we're going to do the same thing here. We're just going to write down those nice numbers. So in my table, I pulled these numbers out. Negative 3 gives me negative 2. Negative 2 yields a negative 1. And my next nice number, 0 and 1, comes at positive 1 and positive 6. And the next number after that is 13, 2, and it doesn't even fit on my graph. But let's take a moment and just graph these. So negative 3, negative 2, negative 2, negative 1, 1, 0, and 6, 1. So g of x is going to look something like that. Okay, I didn't do a very good job there. It really needs to go through that better. There we go. Okay. So down in C, it starts asking us questions about our domain and range. I'd like to keep this in, have some writing on here I'd like to get rid of. There we go. So here we're going to talk about f of x and the domain and the range. And it says state that domain and range of each function below using set builder notation. Now if you remember set builder notation, it uses the set brackets and it starts with an x such that. That line means such that. So what happens here? So I'm going to remind you that domain are our x values, okay? So x values are the lines that go vertically. So I'm looking for my lower bound for my blue function, which is my f of x. So the lower bound seems to be right here at x equals 0, and it never seems to stop because of that arrow that comes over here. So simply I can say my domain of my f of x is going to be x such that x is greater than or equal to 0. Now before moving to our range, why don't we take a look at g of x over on the right side here. Now g of x is my green, right? So look here, see how we started here with our 0. Everything's moving here. where do we start with? There we go. All right, so where do we start with my green function, the g of x? So this one started at 0. This one's going to start over here at -3. And again, it's never going to have an upper bound. It's going to keep going on forever and ever. So that g of x is going to be, I'm going to rewrite that one now. This is use the set brackets, x such that x is greater than or equal to -3. And now we're going to do the same thing with our range, but now vertical is the domain. So now what we're going to do is let's consider our horizontal. Where is our lower bound for our y's? So if we look here, we're going to do the blue one first. That's going to be our f of x. It seems to start right here. And what is that? So that's y equals -2, y equals -1, y equals 0, y equals 1. So this starts at y equals 0. And will it ever stop? And now it looks like it might have an asymptote going on here, but it actually doesn't. The graph keeps moving. All right. It actually doesn't. It will actually keep increasing. So on our range, now remember our range are our y values, so y such that y is greater than or equal to 0 as well. Okay? But now on the next one, let me see if I can just pull that up just a slightest bit. All right, so our range here now is going to be y such that y is greater than or equal to what is going to be our number here now. So this one, I'm going to remind you, here's -3, -2, -1. So right here is where it's going to begin. So y is going to be greater than or equal to -2. All right, and again, it's never going to stop. It's going to keep increasing as it goes off to infinity. Okay? Write down what you need to before we move on to exercise 2. Exercise 2 says which of the following equations would represent the graph shown below. Now, a couple of people will say, well, why not just graph them all? And I agree with you 100%. Whenever you're trying to match a graph or find the equation of a graph that matches it, graph them all and see which one makes sense to you. All right? But I just want to remind you that because I know, I'm going to remind you that the original graph that we did, that f of x, that's called our parent function. All right? So I know what's different between this function and the function that's shown here. Well, it's reflected over the x-axis, which means that my square root of x has to have negative in front of it. All right? So, because that's what flips it over that x-axis. The next thing is it translates 4 units to the left, which means that I'm going to need underneath my radical, if it translates 4 units to the left, we're going to put the opposite, so x plus 4 underneath. All right, so the correct answer here is number 1. We'll talk about that a little bit more, but like I said, this one was so much easier to just put into our calculators. Exercise 3. So exercise 3 says, which of the following values of x does not lie in the domain of the function? And then explain why it does not lie there. Well, some people say, well, I can put this in the calculator and take a look at the table. But it's so much easier to say, I know that x minus 5 must be greater than or equal to 0 because we know it cannot be negative. So add 5 to both sides. And I know my domain has to be all numbers greater than or equal to positive 5. So all numbers here are greater than or equal to positive 5 except for 2. And explain why? I think you can just say because 2 makes our radical negative, and you can't have a negative underneath the radical. So exercise 4 says determine the domain for each of the following square root functions. Show an inequality that justifies your work. My apologies, there is a typo right there. Your work. So all you have to do here is set each of these greater than or equal to 0. So here I have x plus 2 has to be greater than or equal to 0. Here I have 3x minus 2 has to be greater than or equal to 0. And here I have 8 minus 2x has to be greater than or equal to 0. So why don't you take a minute, pause this video, solve for x on all three of these, and then come back and check your work. Okay, are you ready for the answers? Okay, so hopefully you didn't have any trouble with those. The only thing I wanted to bring to your attention is under C, make sure you remember when you come down to this point right here and you divide by that negative, that changes your sign direction. All right, so make sure that you're at x is less than or equal to 4, not greater than or equal to 4. Okay, number 5. So consider this function. This is a really great example of really intertwining everything that we've done in this course so far. So this says use your calculator to sketch the function on the axis given. So when I first looked at this and I set up my calculator and I opened my calculator, I went here and I did x, y, and I came up with some numbers. Like I came up with 2, 3, 4, which was 0, 3, 4.5, 8 turns out to be 9.16. So by the time we were all done with this, it started at 2, 0 here, and it went up something that looked like this. All right? But the funny thing is, I thought about this for a minute, and I thought, I wonder what would happen if I went up a little bit more, and actually, what happens is you have another one that starts on the other side. So let me show you what I'm talking about algebraically down here on B. All right, so now I take my original, this is my original, x squared plus 4x minus 12 is greater than or equal to 0. I factored it, because the only way I can solve a quadratic is by factoring it or using the quadratic formula, and I get x plus 6, x minus 2. So my bounds are going to be negative 6 and positive 2. So if I look that on my number line, I get negative 6 here, I get 2 here, I have a greater than or equal to, which is going to be two solid circles, and because it's greater than, it's going to be going to the outside, right? So I'm like, wow, I think I need to look at a couple of more numbers on my table. And so when I went back here and I looked at my table again, I started seeing numbers negative 6, 0, negative 7, 3, negative 9, 5.7. And so I noticed that this actually at 1, 2, 3, 4, 5, 6 at negative 6 had something that looked like this. Had this beautiful even function that's symmetric around actually, no, it's not even because it's not symmetric around the y-axis. It is symmetric around a line, but not the y-axis. Okay, so I thought that was really very interesting. So that's a bit about it for today. Exercise 5 in class, we'll be doing the classwork for this. And I think these are kind of fun because I think they're not that hard and they're kind of easy to figure out. Just be wary of those quadratic square roots because they don't look exactly the way the single square roots look, okay, or the linear square roots. So until next time, make good choices, be kind to one another. Bye.